Standard GPS puts you within a few feet. RTK puts you within inches, precise enough to accurately geotag every mapping image for pixel-level georeferencing, to place the camera in the exact same position on a repeat flight, and to land with pinpoint accuracy. I'm Chris Robbie, Global CTO at ACSL. In this video, I'll walk you through everything you need to know about how to get our new RTK module set up and flying on SOTEN. With RTK active, SOTEN maintains inch-level position accuracy throughout the mission. No post-processing required. Your mapping data is georeferenced in real time, directly on the aircraft from the moment of capture. One note for operators familiar with other systems, SOTEN does not support PPK post-processing. RTK via a live NTRIP correction stream is your path to inch-level precision. RTK works by comparing SOTEN's raw GNSS observations against a reference point with a precisely known position. The difference, or the correction, is sent to the aircraft in real time, allowing its GNSS receiver to resolve its position to within inches. In SOTEN's system, the correction data travels like this. The TAITEN controller receives the NTRIP correction stream over Wi-Fi, then forwards it to the aircraft over the radio uplink. The aircraft itself does not connect directly to the internet. The controller handles that relay. So far, SOTEN has worked with every NTRIP correction stream that we've tested. The two most common setups are a correction service provider like GeoNet over a standard internet Wi-Fi connection, which is straightforward when you have connectivity in the field, or a local base station that broadcasts its own Wi-Fi hotspot like this Reach RS2 here, which works great in remote areas when you don't have cell coverage. One important operational note for the base station hotspot scenario: when the TAITEN controller is connected to the base station's Wi-Fi, that network interface is occupied, so map tiles cannot be downloaded during that session. If you plan to use a base station hotspot in the field, download your mission area maps in takeoff ahead of time, before you leave for the site. The RTK module is a single unit with 4 integrated screws and an integrated USB-C cable. To attach it, you'll need a 2.5mm hex driver. The USB-C cable has a silicone boot at the connector end. That boot seats against the aircraft's USB-C port to keep dust and water droplets out. Before you attach the module, power the aircraft off completely. This ensures that the module will be properly recognized during startup. The module mounts to the 4 hardpoints on the top of the aircraft. Align the module to the hardpoints, making sure that the USB-C cable leads to the right side of the aircraft. Use your 2.5mm hex driver to tighten in a cross pattern a few turns at a time. Snug them down evenly and do over over-torque. Now connect the USB-C cable. Seat it firmly into the port on the side of the aircraft until it clicks. Then press the silicone boot flush around the port opening. The boot seals the connection against dust and moisture. Make sure that both the connector and the boot are fully seated before flight. Remember, this USB-C connection is the RTK module's only link to the aircraft. Make sure to check it before every flight. Next, power on the aircraft and the controller. In takeoff, you'll know that the RTK module has been properly recognized if you see the RTK icon at the top of the flight view. Open Settings, go to the Drone group, and select RTK. For this example, we're using an MLID Reach RS2 base station in local NTRIP mode with its Wi-Fi hotspot enabled. In this case, we enter the address, port, username, password, and mount point as specified by the MLID app connected to the RS2. But this will be similar for whatever service you choose to use. Once all fields are filled, tap Start RTK. Once the connection is accepted, watch the RTK status indicator at the top of the screen. A red exclamation point indicates that GPS is not yet corrected. As correction data begins arriving, it will transition to a yellow exclamation point indicating RTK float, and then the exclamation point will disappear indicating RTK fixed. Float to fixed typically takes 30 to 90 seconds with a clear sky view. RTK float does provide improved accuracy over standard GPS, but fixed is what gives you the inch-level precision. Don't launch until you have RTK fix confirmed. Here's a short autonomous survey mission with RTK fix active throughout. The aircraft holds its planned track reliably, and the resulting data is georeferenced in real time. No ground control points required. If you're not getting RTK fixed, keep in mind that RTK requires a clear, unobstructed view of the sky. Trees, buildings, or vehicle rooftops can reduce satellite count enough to prevent a fixed solution. Reposition either the aircraft or the base station if necessary. If, when starting the RTK connection, you get an error like network connection unavailable or RTK service timed out, check that your Wi-Fi is turned on and connected to the appropriate SSID, and that the address of the NTRIP service is input correctly. Takeoff will let you know if you input the port, mount point, or credentials incorrectly. These are often case sensitive, so make sure that you enter capitals and lowercase characters correctly. If you're failing to download map tiles while connected to a base station's Wi-Fi hotspot, this is expected behavior, not a bug. While the controller is connected to the base station's network for RTK corrections, it can't simultaneously reach the internet for map data. The solution is to use Takeoff's offline map feature to pre-download your mission area maps in Takeoff before heading to the field. If the RTK icon doesn't show up at the top of the screen in Takeoff, the most likely cause is an unseated USB-C connection. Power down the aircraft, reseat the connector until you feel or hear it click, and confirm the silicon boot is fully pressed around the port. Power back on. If the module still isn't detected, power down again and blow out the connector at the end of the cable and the aircraft's USB-C port with a can of compressed air. Debris in either connector can prevent a solid connection. Reseat and power on once more. A reminder on safe operation. RTK adds precision, but it doesn't change your responsibilities as pilot in command. Keep your eyes on the aircraft at all times. The USB-C connection between the RTK module and the aircraft is a cable, and cables carry a small risk of intermittent contact. If you observe any unexpected behavior in flight, take manual control immediately. Standard visual line of sight rules apply. If you still have questions or you have feedback on the RTK workflow, contact us at info@acsl-usa.com. If you're doing something interesting with RTK-enabled SOTEN missions, leave a comment below to tell us about it. Your input directly shapes how we develop Takeoff, the RTK feature set, and our future products. Thanks for your interest in ACSL, fly safe, and blue skies ahead.